Hey everyone, Kevin from TechSelect here, and today I wanted to introduce our newest product, the RGBtoHDMI. The purpose of this board is to convert EGA, CGA, Monochrome, and several other TTL-based video signals to HDMI. It's a recreation of Hoglet's awesome open-source project, the RGBtoHDMI board. It also integrates EanB's 6-bit TTL buffer board. We have been selling the MCE to VGA board for some time now, and recently the price for some of the parts has more than doubled. The MCE to VGA, while very handy and cool itself, does lack a few features which would be helpful. In addition, it outputs VGA instead of HDMI. This still requires a somewhat older display, and as time goes on, HDMI will offer more flexibility. The real advantage is that the RGB to HDMI interface offers a far superior image quality in almost every situation. It supports many more video signal types and is really designed to be the Swiss Army knife of video converters. What I mean by this is that it can work with not only digital but analog signals from a wide range of devices. And while I really like the concept behind the project, understanding how to use the various shields and cabling options can be daunting. It actually took me a fair amount of time to understand the capabilities and what hardware was needed for each scenario and what cable. After more research, it also seems like people will often install the board in a system to permanently convert it to HDMI forever. But with our board, I really wanted to make it a simple and off-the-shelf converter to work as a replacement for the MCE to VGA. This means it will only support 6-bit or less TTL signals, and I permanently installed a DB9 connector on the board. This makes it very simple to connect any 9-pin D-sub style video card, which is common to vintage PCs. Several other systems have this connector, such as the Commodore 128, and it too will easily plug in. In addition, a cable could be made to support almost any other supported digital source. EanB's 6-bit TTL input buffer is integrated to help with signal integrity over long or noisy cables, and it will offer some protection for the CPLD as well. I designed a 4-layer PCB to ensure the best noise rejection, and the result is an amazingly clear signal like I've never seen on any other converter. It comes pre-assembled, including a 4GB microSD card to hold the operating system for the device and to store screenshots. The board includes the needed Raspberry Pi Zero, which uses a mini HDMI connector for output. We include a USB cable to provide power and a mini to standard HDMI connector to make connection easy. It's designed to be as simple to use as possible. Out of the box, it will convert EGA, CGA, or Monochrome. However, there may be some tweaking necessary to get the best output for your situation. It also has an on-screen menu which allows you to change settings easily. So why no analog support on our version? Well, the board has a CPLD to assist with video signal handling, and it behaves differently from digital to analog sources. To switch between sources requires reprogramming the CPLD, and while this is a rather simple task and is actually built into the hardware, it is a less simple matter to allow switching between the TTL input buffer and the circuitry required for analog signals. I did attempt at doing so initially, but I later decided it would be better to make separate adapters for this task. The TTL version certainly seems to be the most useful for vintage PC collectors, so it seemed the most obvious place to start. I'm also very happy that this project is still active and producing updates and fixes as time goes on. This wasn't really the case with the MCE to VGA, and like the MCE to VGA, the RGB to HDMI does still have a few operational quirks. One of the primary issues I've encountered is while switching video modes. This issue is most pronounced on EGA cards when switching back to CGA modes. This can be fixed, but it does require making a change in the on-screen menu at times. In addition, much like the MCE to VGA, at times the syncing of the video signal may be slightly off and requires you to press the Genlock button to fix image stability. However, once you're locked into a specific video mode, it seems to stay pretty stable and looks amazing. For these tests, I'll be using the Packard Bell PB500. This machine is a little slow, but it's really clean, don't you think? Here are the 3 video cards I'll be using to test the RGB to HDMI: Monochrome, CGA, and EGA. And what video would be complete without a shameless plug of our other products? The 2 meg EMS, the compact flash adapter, as well as the bracket kit, and of course the ReSound 2 OPL3. And here I'm hooking up the power for the compact flash adapter. The first card I'm going to test is a monochrome display adapter. Picture may be a little blurry here, but what I'm trying to show is the PB500 and the RGB to HDMI hooked up at the same time to an HDMI monitor. On certain monochrome cards that I've used, it seems like the default profile doesn't line up properly and some adjustment is necessary. Well, not quite. Let me try it again here. Just a quick check of the system info to show that there is a monochrome card installed. A little benchmark for the system just to show how fast it is. And a quick benchmark of the card, just because. Monochrome mode doesn't really have too many video modes to work through, but you'll notice the RGB to HDMI has a solid red LED, meaning that it's synchronized the whole time. Pay attention to that when we do the CGA test here in a second. Now it's time for the original IBM CGA card. The first step is to go into the on-screen menu for the RGB to HDMI and select CGA. You may notice some green glitching on the screen. Well, that's not the RGB to HDMI, that's actually the original IBM CGA card doing that. If you're familiar with them, I think this is called CGA Snow, so it's a known issue, but even the RGB to HDMI picks it up. Another quick show of system info to show the CGA card. And I just couldn't resist running the test again just to show that snow one more time. So here's where you'll start to see some behavior from the RGB to HDMI where it's trying to change between video modes and CGA and synchronize the signal as best it can. The screen will go black and the LED is going to flash until it can synchronize the proper mode. You may have noticed I've been speeding the video up at various times, but I decided to leave this portion uninterrupted so you could see how long it takes at times for it to synchronize while switching modes. I know it seems like it may take some time for it to synchronize, but the reality is most games and most programs you're using don't switch this rapidly, so other than running the video test itself, you're not likely to see this in practice. Earlier in the video I was showing some EGA gameplay, and I decided for the EGA test I would go ahead and run it through the capture device that I bought from Amazon. I picked this up just a few days ago for about $40, and it doesn't work perfectly, it seems to have some synchronization issues, but overall it works very well. As always, the first thing to do is to make sure your menu is set for the proper mode, in this case, EGA. Much like the CGA test, the screen will momentarily go black while switching modes. The HDMI capture device that I bought doesn't seem to like switching between modes in certain cases, and it seems to get stuck. I don't really think this has anything to do with the RGB to HDMI necessarily, as it seems to work just fine on a regular monitor, but just be aware if you're using a cheaper HDMI capture card, you might see something like this. For the rest of the video, I'm just going to show clips of a few more games that I recorded. I just can't get over how great they look, and I just thought I would share a few more before the end here. Thanks for watching, everyone, and take care.